Good afternoon, everyone. Am I audible to you guys? Am I audible?
Yes, ma'am.
Okay. Okay, so for today's lab class, I'll start sorting. The sorting unit we will discuss in theory in next week, but all the sorting algorithms and programs are in syllabus, so we are going to do that. So first, I'll start with the bubble sort. I guess you guys already know about the bubble sort. That one was in second sem, but yeah, there are new students. But anyways, do you have any ideas about bubble sort? Any idea? Okay, first tell me why we need sorting. Why do we need sorting? What do you understand when I say sorting? You need to sort something. For arranging lots of elements, so it becomes easy to find some of them. Yes, that's correct. So sorting can be like anything which is messed up. Suppose you can see your all of your books are messed up in your room and you cannot find those books. So what will be the easier way to find a particular book? So you can do one thing, you can just arrange all those books in a particular order. Maybe you can arrange them in terms of the name, like starting from A to Z. Then again, you can start with different types. So just like in dictionary, all words are arranged from A to Z, right? So that's kind of sorting. Again, if I ask you to there are like suppose 10 to 15 numbers and all those numbers are written in some play card and I'm asking you to sort them in ascending order. You will just put them one by one, right? So sorting is nothing but to arrange all unordered things. So bubble sort is the most easiest one. What we do in bubble sort, we just compare the adjacent elements and swap their positions if they are not in intended order. Okay, wait. Let me share my screen. The same will be in the theory part too. So you can say it's for both. So in case of bubble sort, you will just compare the adjacent elements and swap their positions if they are not in intended order. So order can be both in ascending or descending order. Then how does it work? So first you will start with the first index. So you will just compare the first and the second element. If they are not arranged, means first element is greater than the second element, they swap. Then again you will do the same thing for the second and third element. Then again you will swap them if they are not in order. So this process will continue until means all the elements are in arranged position. So after every pass or after each iteration, the largest element among the unsorted elements is placed at the end. Okay, so suppose this is an example. You need to arrange 4, 6, 1, 5, 2, 3. So I need to arrange it in ascending order. Most of the time bubble sort we just do in ascending order. Okay, remember for binary search we need to sort the elements first, then only we can perform binary search, right? Because the main condition for a binary search is that the array has to be sorted. So in this case what we will do first, I'll compare the first and second. What is first and second? 4 and 6. Now 4 is less than 6, so they are already in sorted order, so I'll do nothing. Okay, next is your 6 and 1. Now 6 is greater than 1, so I'll just swap the position. So after swapping, the value will be this one. Okay, so next I'll compare 6 and 5. Now again 6 and 5, 6 is greater than 5, so I'll swap the position, it will come here. So after that again I'll compare 6 and 2 and those will be swapped, and finally I'll compare 6 and 3 and I'll swap the value. So finally after the first pass, this is just the first pass, the highest element which is 6 comes to the last position. Okay, next the same process will continue. Now it's 4 and 1, so again same process will be done. 4 and 1 will be swapped, then again next two position and so on. So finally 5 will come to the second last position because 5 is the greatest one. Okay, so in this way everything will be done. So finally we will get the final 1, 2, 3, 4, 5, 6. Okay, so what will be the complexity analysis of a bubble sort? In the first pass, number of comparison is what? N minus 1. Why n minus 1? If there are six elements, then the number of comparison what? It will be 5 comparisons. After 5 comparison, the highest element will be at the last position. The second pass, 1 is already sorted. We are going to do nothing about that. So in the second pass, the number of comparison will be a bit less. It will be n minus 2. That means 4 elements. Again for the third pass, it will be n minus 3 and so on. So last there will be just 1 element. So if you just write in a um, means add all these comparisons, this expression can be written as n into n minus 1 divided by 2. I guess this series you guys are already aware of that because it was in maths. It's a simple maths. This expression can be evaluated as n into n minus 1 divided by 2. So it will be nearly equals to n square. There will be some constant part. Of course, we can just ignore those constant part and complexity will be O n square. Okay. So the time complexity means worst one is O n square when the element will be like completely in disarrange. Like suppose whole array is in descending order and we need to convert it into ascending order. That means it will have to perform all this comparison and worst case will be O(n) square. For the best case it's O(n) and for average cases also O(n) square. Space complexity is O1. Why O1? Because numbers are already there. We are just comparing them and swapping them. So space complexity is just O1, which is a constant. Are you guys clear about this one? Bubble sort, how it's performed? Yes, everyone, yes. Here, Abdullah, Iba, Dollar, wait, yes. So it's the simplest one. You will just compare it adjacent elements. Then you will swap. Yeah. Okay. So let's just see the program. Okay, this is the program I'll share with you guys. You guys can try too. So the simple program is just normal C program. All we need to do is what? We need to swap the values. So first in this program, just taking an array of 100, then we are taking a swap variable. So first for this program, we need to enter the number of elements we want in the array. Then accordingly, we will store all those values. Then here it's just swapping. I guess you guys are already aware of this swapping element. So one by one, we are going to read the values. So here you can see C is C0 and C less than n minus 1. That means we will check this until the last one. Then this loop is for the second one. Okay. Means we are again checking from the second element, because first we compare the first two neighboring element, then we check the next two neighboring elements, and so on. So finally in this one we are checking if array D is greater than the next position D plus 1. If yes, then we will just swap the value. First we will just keep the value of this D in a temporary variable swap. Then we will again set this up. So this is just swapping program. You guys are already aware of this. So finally we will get the ascending order. So if I run this one, number of elements maybe 6, 28, 34, 7. Okay, so sorted arrays 17, 22, and so on. Okay, so I'll share the program with you guys in the group. You guys can try and just let me know if it's working in your case too. Okay, so clear bubble sort. The same bubble sort also will be in the theory portion. We will discuss in next week. So since I have already covered the bubble sort, we can just go to the next sorting algorithm. But if you guys have any confusion, I can discuss again. So clear, everyone? Bubble sort. Okay, if yes, I'll just end the meeting here. I'll share the thing with you guys. So I'm just ending the meeting here. I'll share the program in the group. You guys try. Okay. Thank you.